gents, welcome to our first video on sequences and series. This is going to be a very short video just to get you familiar with the 5 different formulae that you'll encounter and the meaning of each of the variables, just so you have a good understanding before we have to apply them in subsequent videos. You need to make sure you are able to rearrange equations algebraically, being able to put like terms together, rearrange equations to make to isolate a variable, that sort of thing. So if you're a bit stuck up on that, you may want to search some of those things on Education Perfect or get in contact with me. So all those variables that you just saw in those formula, what do they mean? Well, the t sub n just refers to the general term. So in a sequence, each term is a value, and we call those general terms. The n tells us which place in that sequence that term belongs. So for example, if the n was worth 10, back here it would be the 10th term. So you would count along to the 10th value in the sequence and you'd be able to identify what that general term is. A is the first term in the sequence or the series, the one at the very start, or t_1. D is the common difference between terms. So if we had term 1, term 2, term 3, and they had different values, the difference between those values would all be the same number, and that's defined as the common difference, and is represented by the variable d, and that only appears in an arithmetic sequence. The R refers to the common ratio, which only appears in a geometric sequence or series, and that is a difference between terms in that particular sequence, and it's always shown through multiplication. The difference is shown through addition or subtraction, but we'll get into that with a must-know number 3. S sub n is the sum or total of all the terms in the series up until the nth term. So you would have noticed back on our initial bit of paper, S sub n just refers to the total up to the nth term, okay, the sum of, whereas the T sub n referred to the general term, the nth term. Our last one is this sum to infinity, and that's when we don't know what the end of that series is. If that particular series was to go on and on forever, what would be the maximum or minimum outcome based on that? Our second must know is knowing the difference between a sequence and a series. We always refer to our unit as sequence and series, but that's because there are 2 elements to it. A sequence is just the list of values, a list of numbers that are separated by commas. And they are in a specific sequence for a reason, a logical sequence that follow a pattern. They can be increasing, they could be decreasing, but it is defined as a sequence if it's just referring to the individual list of numbers. A series, on the other hand, is when they've been added together rather than just listed. So you keep adding them up until a certain point. They could be added forever and ever and ever, or they may have a limit, hence the S sub n. Okay, they could also be adding in an increasing or a decreasing amount. So those are our variables and the difference between sequence and series. Our third must know is being able to tell the difference between an arithmetic and a geometric sequence. An arithmetic sequence, as I hinted earlier, is defined by the variable d, and it is found by looking at the terms in order and checking that the difference between them is the same value every time, and it's increasing using addition or subtraction, as you can see in these examples. Geometric, on the other hand, is shown or represented by the common ratio, and I knew I'd run out of paper there, so We'll just pop that in. And it's with the values of a geometric sequence. They increase, and quite often, because the common ratio is shown with multiplication, they can increase quite rapidly, especially as the sequence goes on. So that's one way to recognise it. The difference between the terms is only found by multiplication, even when it decreases, which looks like it's dividing, but we use a multiplication of a decimal or a fraction because that makes numbers smaller. Okay, and remember, we're trying to find the common ratio when finding that difference between the terms. So that's the difference between an arithmetic and a geometric. So how do you find the common difference in an arithmetic sequence and the common ratio in a geometric? So you can actually tell which is which. Here I've written 4 sequences. Straight up, you can't tell immediately which is geometric, which is arithmetic, but I'm going to show you how to go about it. So to find an arithmetic sequence, to find D, you're just taking any 2 terms and you're subtracting one from the other. But you've just got to make sure that for whatever term you choose, so for example, if I chose term 4, I must choose the term immediately before it to subtract. Okay, so as you can see, if I took term 4, I would subtract term 3. If I chose term 8, I would subtract term 7. If I took term 3, I would subtract term 2. I just can't choose term 1 because there is no term 0. Choose term 2, you can subtract term 1 from it. Same thing in a geometric, you choose a term, but this time instead of subtracting, you're dividing. So if I chose term 4, I would divide times term 3. You get the idea. Well, what does that look like in action? I stuffed up a previous video I made, hence the crosses on my bit of paper. But I'm just trying to show you how we went about it. So first up with sequence A, I'm going to look to see if it's geometric or arithmetic. I decided to try arithmetic first because the difference over time didn't happen too quickly. I decided to choose term 2, which had a value of 3, and I subtracted term 1, which had a value of 5. 3 take away 5 gives me -2. I then tried it again with term 3 and subtracted term 2. 1 take away 3 is -2. Both of those are the same answer, -2. I could then go through and check in the sequence. 5 take away 2 is 3, 3 take away 2 is 1, 1 take away 2 is -1, and so on. I've checked to see if that difference works. It does. I've confirmed to myself that it is in fact arithmetic. But just to prove that it isn't geometric, I took term 2, which had a value of 3, and divided it by term 1, which had a value of 5. 3 divided by 5 gave me 0.6. Term 3 divided by term 2, which was 1 divided by 3, gave me 0.33 recurring. 2 different answers, can't be geometric. Just while I've made this point though, if you ever get a really messy decimal, one that you have to round when working something out, please leave it as a fraction. A fraction is more accurate than any decimal that you've had to round. So again, unless it's tidy, like 0.6 was a tidy decimal, I could use that, but I couldn't use 0.333 recurring. There's too much of a margin of error. I discovered that sequence B was also arithmetic because I got 1 1/4. Take away 1 gave me 0.25. That was term 4, take away term 3. 3/4 take away 1/2 also gave me 1/4, or 0.25. Same answer. It was definitely arithmetic. When I tried to do it geometrically and divided them instead, I got 1.25 and 1.5 respectively. They're different. I trialled it in the sequence. I added 1/4 each time, or 0.25, and it worked. In sequence number C, 1 to -3 to 9 to -27. Now here we've got an alternating pattern. If you ever have an alternating pattern and it's geometric, I'll explain what the common ratio will be, okay? I tested to see if it was arithmetic. Term 3 take away term 2, 9 take away the negative 3 because the value was a negative 3. I can't just go 9 take away 3 because take away is part of the formula. I had to substitute in negative 3. That gave me 12. Negative 3 take away 1, which was term 2 take away term 1, gave me negative 4. Well, I've got two different answers. It's not arithmetic. On the other hand, when I did divide term 3 divided by term 2, 9 divided by negative 3, I got negative 3. Negative 3 divided by 1 also gave me negative 3. I got the same answer, so my common ratio is in fact negative 3. So if I multiply it, if I check it, 1 times negative 3 gives me negative 3. Negative 3 times negative 3 gives me positive 9. 9 times negative 3 gives me negative 27. Now you may have noticed that we had positive, negative, positive, negative. If you see a sequence has that sort of pattern to it, you know that it's going to be geometric. It has to be. It can't go backwards and forwards up the number line in an arithmetic sequence like that. So if a geometric sequence is alternating positive, negative, it means your common ratio has to be negative as well. You can't get a positive and a negative with a positive common ratio. So that's just a little hint. If you want to give sequence D a go, which has a decimal on the start there, try and do the same thing and see if you can get it to work. Good luck with that. And that's the end of the first video. The next video is going to get into using our arithmetic general term formula to find a general term, to find the first number in the sequence, to find where in a sequence a value actually sits, and also to find the difference. So I'm going to show you how to manipulate that whole formula to find any variable in there. We will also touch on in that video the use of simultaneous equations when you're missing two variables and you need to find one in order to find the other. Alright, I hope that was helpful, boys, and I'll catch up with you in the next video.